Welcome to part 2 of the naming and representing the formula of organic compounds. So in here we are going to name some more complex, different molecules, and we're also going to draw some more complex molecules. So let's get on with drawing the hydrocarbons. Now this video is just about hydrocarbons. As you go through the videos, we'll go through different types of functional groups, but for today just hydrocarbons. So identify the type of hydrocarbon. Today it's going to be alkane, so it ends in A-N-E. Identify the stem, the longest chain. You just go along the form and say, where can I get the longest chain? Where is it? We'll do that in the examples. Identify the branch. So this is the branch coming off the longest chain, and we put the branches as aisles, so YL, and we identify the number of carbons in that branch. So for example, one carbon would be methyl. Then we decide on whether it's a prefix or a suffix on this longest chain, this stem. Today, the alkyl groups, all those branches, are always going to be a prefix, but in other ones you might find they're a suffix. But we'll talk about that when we get into other functional groups. So let's put this to the side and look at our first example. So our first example is 3-methylpentane. We're going to do this in molecular formula, displayed formula, skeletal formula, and structural formula. So you can see here, this is 3-methylpentane. We identify, first of all, it's an alkane. So we've got the A and E. That's our first one, A and E. Then we look here, where's the longest chain? Well, the longest chain is the pent. So that means it's 5 carbons long. Then we have the aisle, which says it's a branch, and there's 1 carbon in that. And that branch is at number 3. So if we then start to do the different types of formulas, so let's do molecular to start off with. Well, we know we have 1 plus 5, which is 6 carbons. So molecular formula, C6H, and at this point it's an alkane. So the general formula of an alkane is CnH2n plus 2. So we follow CnH2n plus 2, and we just go C6 times 2 is 12, plus 2 is 14. So that's our molecular formula to start off with. We then do our displayed formula. So displayed formula, we know that the longest chain, we all start with the longest chain, so there's my longest chain, 5 long. We know there's a branch at number 3, so let's go 1, 2, 3. You can count from either end, doesn't matter. Okay, and then we look here and go, that's number 3, and there's 1 carbon coming off number 3 because it says methyl 1 carbon. We then fill all the hydrogens in, and all we're doing here is counting the bonds. So remember, there is 4 bonds for each carbon, and I've now just put the lines in to say there's 4 bonds for each carbon. And then I put my hydrogen in here. Okay, so we've put our hydrogens in. Let's not forget any. So hydrogens are in. And you notice how long that took. Why? And this is why I'm saying to you, get good at other types of formula, because this one just takes far too long. Right, from that point we can do structural formula. So we can say, right, okay, what's on each carbon? So there's a CH3 here. There's a CH2, 2 carbons. So 2 hydrogens, sorry. Okay, then there's a CH. You can see a CH there. Now, that CH3, which you can see here, okay, that is coming off position number 3. And so if you want to do it when you're doing structural formula, say this comes off that 3rd carbon. Well, the 3rd carbon is this one here. Okay, so if I put it in brackets, and I put CH3, this CH3 is that CH3 there. And by putting it in brackets and after that carbon, I'm saying this comes off number 3. Okay, it's coming off number 3, bonded to number 3. We then go to number 4 here. That's a CH2, and number 5 here, which is a CH3. So we've done our structural formula, and let's just get rid of these numbers. I don't want these to confuse the end. So you can see, look, there is our full structural formula. Now, if we then go to our skeletal formula depends on the pent. So that's 5 carbons. So start off, there's my first carbon. 2 carbons, 3 carbons, 4 carbons, 5 carbons. So that's 1, 2, 3, 4, 5. Okay, Then, at this point, you look at number 3 and say the methyl is at number 3, the methyl's number 3 there and there. So I just draw a line because that's a carbon. So it's saying one carbon is coming off position number 3. So what we've done is we have from 3-methyl pentane done our molecular formula. We figured that out using the general formula of alkanes. We've got our displayed formula, our structural formula, and lastly, the easiest and the quickest, and the one I really want you to get good at, skeletal formula. Our next example is 2,5-dimethyl decane. So we're going to do exactly the same thing. Identify the type of molecule we've got, alkane. We've got the dec, which is 10. And we've got methyl. Now, the important difference here, there is one carbon coming off because it's methyl. So monkeys eat proper big peanuts. Methyl is the first one. But we've got this little thing here, which is a di. Now, this tells us how many methyls there are. So it's mono, di, tri, tetra. Okay. And if you look there, that means there's 2 methyls coming off. And not only that, it tells you that they are at 2 and they are at 5. So let's start off as we did before and do the molecular formula. So the molecular formula means that we have 2 times that methyl. So that means we have 12 carbons in total. C12 is CnH2n plus 2. So that means C12H26. And again, nothing stopping you stopping the video, doing all this yourself. Then we look at this, okay, and it comes to, let's just think about this in displayed formula. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we look at there and we go, right, okay, we've got 2 and 5, so dimethyl. So there's number 2, there's a carbon coming off number 2, there's 1, 2, 3, 4, 5. Okay, so there's a carbon coming off. Now, I've drawn that as a chain. And I've done this deliberately like this just to show you why it's really good that you get good at the other ones, because this just takes far too long. Now I've got to put in all the hydrogens. I'm not going to put in all the hydrogens. Feel free to do so yourself because it would take too long. But you'd have to put in all the hydrogens. It'd take you a very, very long time. So there's a way in which you can do it as well, which I'll show you. Let's do structural. So that would be, and I want you to count, and we'll do a few of them just to, okay, so that would be 3, so CH3. And then we look here. What do we think this is going to be? Okay, that's a CH. There's my CH. Then we look up here. There's my CH3. Again, just because formula, that carbon's coming off here. So it's a bracket. And there we go. And just because I can't stand not having it on, we will do it as we go along actually. So here we go. Here's the CH2. There's my CH2. There's my CH2. Okay, and I've got 2 CH2s, and then I've got a CH again. And there's my CH3. Okay, CH brackets because that CH3 is coming off that carbon. And here's the trick here. So we're getting to this point where it's getting really, really messy. So basically we put all the hydrogens on here, and if you'll notice that they're all CH2s. So they're all CH2s, and there's quite a lot of CH2s here, actually. Okay, there's 1, 2, 3, 4 CH2s. So instead of writing out structural formula and doing loads and loads and loads, what I can do is actually I can say, right, okay, I can put that and put that in brackets and then say, right, okay, there's 4 of those in a line. So that's telling me that there's 4 CH2s coming off in a line, and then we finish off with a CH3. Okay, so question is that would you be asked to do structural formula of something this long? Probably not. Is it good to practice so you know it? Yes, it's good to practice so you know it. But this is really, really long. Now, if I was going to do this, my choice would be skeletal formula every single time. So if that's it, we're going to do 10. So 1, 2, 3, 4, 5. So we've done 5, 6, 7, 8, 9, 10. And you saw how quick that was. And then we go to 2 and 5 and dimethyl. So that's 1, 2. There's my 2, 3, 4, and then 5. And there you go. You saw how quick that was. to draw that skeletal formula out. So we've got this really complicated displayed formula, it takes ages. Highly unlikely they'll ever ask you to do that in A-levels because it just takes far too long. You've got the structural that is fiddly, okay, and this size of molecule probably not going to be asked to do this, but you might be asked, for example, to do the skeletal formula because it can be done very quickly and easily, so make sure you practice. We're now going to move on to naming hydrocarbons. So there's two rules that we need to really look at first. When numbering, use the earliest numbering system. I'm going to explain what that means when we look at this molecule. All functional groups or branching must be written in alphabetical order when you write out the name. So again, we'll go through this when we're looking at this molecule. But before we do all that, we'll go back to our rules. So our rules are identify the type of hydrocarbon. So you can see here, this is an alkane. So because it's an alkane, we can identify the stem, the longest chain. And if we look here, let's count. So we've got here 1, 2, 3, 4, 5, 6. So we've got 6 in that direction. 1, 2, 3, 4, 5, 6, 7, 8. So the longest chain is this chain here that goes 8 carbons in length. Now because that's 8 carbons in length, we can then start to see what's the earliest numbering system. So our branches, and we're going to identify those branches now, we can see that if we're going in this direction, the branches are on number 2. So we've got here, we've got number 1, okay, and then we've got number 2. And we see 2 branches, a methyl going that way and a methyl going that way. So that's number 2. So let's go to the other end of the molecule and go, right, okay, where's the earliest number on this one? So 1, 2, 3, 4, 5. So I've got 2 carbons coming off at number 5. Now there's 2 carbons coming off number 5 in an ethyl group, because monkeys eat proper big peanuts, remember. Eth stands for eth and an ethyl group, so 2 carbons. So this is an ethyl group, and that would be at position, I'll do it again, 1, 2, 3, 4, 5. So that would be at 5. So the earliest numbering system from that end is going to go 5, and the earliest numbering system for the branches from that end is 2. So we're going to name it from this end, because it's the earliest numbering system, and it obeys that first rule. If we then put our numbers in fully, there we go, 3, 4, okay, and just to make sure you know all of the carbons, so we've got 5, we've got 6, 7, and then we've got 8. So we've got 8 in length. So that means naming this is going to be oct. And so there is our name of our alkane. We know it's an alkane, so it would be octane. And then we go and look at our branches. So our first branches are going to be methyl. So these 2 ones down here are methyls, because they're 1 carbon long. And then this one up here is going to be an ethyl. So then you look at those and you go, right, okay, what numbers are those ethyl on? So this is going to be, the methyl is going to be on 2. So that's going to be 2 and 2, because there's 2 of them, 2, 2. And that's going to be di. That's 2,2 dimethyl. Then we look at the ethyl. The ethyl is at position number 4. So that's going to be 4 ethyl. So we've got our groups, and now we need to decide how we're going to put them in the main name. So the main name, and this is where the second bit comes in, all functional groups and branching must be written in alphabetical order. So you don't do the alphabetical order of the mono, the di, or the tri. So in chemistry, mono meaning 1, di meaning 2, tri meaning 3. You don't include this. So this bit here, you are not looking at that D to look at the alphabetical order. You're looking at the M for the actual branch. So if we compare the M to the E. So the earliest in the alphabet is the E. Okay, so the E comes first. So what we'll do when we're doing this name is we're going to look at ethyl. So it's going to be 4 ethyl. So we've done 4 ethyl. Notice they're separated by these kind of hyphens, okay? And then we go, right, next one is 2,2 dimethyl. So 2, comma, 2, really important, you put a comma between the numbers, and then it would be di, and let's try and fit this in, Okay, dimethyl. So the full name of this is 4-ethyl 2,2,2,2 di, as in 2 methyls, dimethyl octane. And that's how you name the first of our examples on very complex large molecules. Here's our final example of naming hydrocarbons, which is, as you can see, quite a complicated one for you to do. As said before, stop the video, try and do it, try and name it. So what we're going to do is go through it and do what we did before. So what type of molecule is it? Well, it's an alkane. So we're going to end in A-N-E. It's going to be a big long name going across here, so let's give ourselves some space. And then we look at the longest chain. So we're looking at the longest, the parent chain, the stem. So we start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. But we've got other branches coming off. So what if we start from here? 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll start from this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically it doesn't matter which one it is. The longest chain is 9. Now 9, hopefully you remember, is non. So this is nonane. So from there, we've got quite a lot of branching going off, so we're going to have to do some serious naming here. And we look at the earliest number convention. So basically here, 1, and then our methyl is at number 2. So methyl is number 2. If we go the other end and we start looking at where's the branching here, so there's 1, 2, 3. The earliest number is 2, it's not 3. These ethyls are coming off number 3. So we're going to go with 2. So then from this bit, you go 3, 4, 5, 6, and there's your 7, and there's your 8, and there's your 9. Let's fix that 9. Okay, so there's your 9. So we've got 9 long. So now we can say where are the branches coming off. So we've got a branch coming off here. And that branch coming off here is a methyl. Let's count how many methyls we've got. So we've got a branch at 2, a branch at 4, and a branch at 5. And they're all methyls. The other two are ethyl groups, as in 2 carbons long. So we've got 3 methyls. So if we look at those 3 methyls, they're at 2 and they're at 4. But let's do it a bit different to the last one. Let's just put the word methyl there so we can look at the alphabetical order. And then come down here, and then we go, this is going to be, that's there, ethyl. So we've got ethyl and methyl. So M, E, alphabetical order, E comes first. Okay, so we need to know where those ethyls are. So if we look at where these ethyls are, they are at 7, and there's 2 of them. So that's a diethyl. Okay, and I haven't got much space here, so I'll put this up here. So they're both at number 7, so that would be 7, 7, diethyl. We'll put it properly up here. So if you look at the methyl, 2, 4, 5. So this is 2, 4, 5. It's going to be tri. So let's just write it straight up here. So ethyl comes first, then methyl. So let's put the ethyl up. And let's see whether we get enough space here. 7, 7, diethyl. There we go. 7, 7, diethyl. Done that. Now that's done because alphabetical order. So E comes before M, so that's done first. From there, you've got your methyls, and you have your methyls at 2, 4, 5. So that would be 2, 4, 5. How many methyls do we have? We have 1, 2, 3. So that's 2, 4, 5, and 3 in chemistry is tri, and they're methyls. So there you have it. And there you have the name of this compound, this molecule. 7, 7, diethyl, 2, 4, 5, trimethyl nonane. Nonane, longest chain. There are 3 methyl groups, which is the tri. There are 2, 4, 5, which is the earliest numbering that we can get. Okay, and the ethyls, therefore, are at 7, 7. And that's how you name a complex hydrocarbon.